Welcome again to the Bite-Sized Critical Realist. Today I shall speak to you about an important critical realist concept, and it's called Open Systemic Causality. But first, a short recap. What we have been doing is called clearing the ground. It's the term that John Locke used and which Bhaskar borrowed to describe the task of his philosophy, to clear the ground, to remove the rubbish. Before we can even talk about science and the world that science investigates, it's important to clear the ground. What we have been doing is we have been analyzing the two fundamental methods of the empirical sciences, observation and experimental activity. From this analysis, we have reached two basic insights about the world, two basic insights that will also inform the way we think about and discuss science. When we talked about existential intransitivity, we reached the insight that our knowledge is not the same as reality. And when we talked about depth stratification, we concluded that the world is much, much more than our experience of the world. From Bhaskar, we learned that the world is not only intransitive, but it is also stratified. Not only is the world autonomous of our perceptions and knowing, but it also has three domains. The domains of experiences, events, and causes. And from this, Bhaskar proposes to us that there are two criteria for reality, one more superior than the other. The more common, the default criterion that we use to ascribe reality to something is called the perceptual criterion. Instead of that, we have been offered an alternative criterion, the causal criterion for reality. This means that it's not enough to say that to see is to believe, because just because you perceive something doesn't mean that's all there is to it. Things that can have an effect, things that are causally efficacious, that can make a difference, even if they haven't yet, are also real. Let's take a moment to use this distinction between the perceptual and causal criteria to answer a couple of questions. The first question is, are concepts and beliefs real? And the second question is, are false concepts and beliefs real? Is there such a thing as conceptual reality or social reality that's distinct from natural and material reality? I think we would have to say yes. If we believe that concepts and social structures are causal, then they must be real. In the book Harry Potter and the Deathly Hallows, there is a quote from Professor Dumbledore. He says, "Of course it is happening inside your head, Harry, but why on earth should that mean that it is not real?" Anything that can make a difference, anything that can have an effect, will have to be real. But what about false concepts and beliefs? Are they real? The question we need to ask is, do they make a difference? Do they have an effect? Or can they have an effect? Are they causal? As we know, false concepts and beliefs can make a difference, can be very harmful. They can mislead and lead people to do things that are not right. For this reason, using the causal criterion of reality, false concepts and beliefs are real. This brings us to an important distinction made possible by critical realism. And this distinction is between two concepts that are often mistaken as synonymous and identical. And I'm talking about what is real and what is true. Thanks to the distinction between the perceptual and causal criteria of reality, now we know that what is true is real because it can make a difference, it can have an effect. But what is real is not necessarily true just because something can make a difference does not mean it's true. So far, we have concluded that the world is not only intransitive, but it is also stratified. Now we come to a third conclusion from Bhaskar's analysis of observation and experimental activity. His third conclusion is that the world is also an open system. By open system, what we mean is that the world, unlike the laboratory, has different causes interacting all the time, and together they co-determine events. This is not what happens in a laboratory because of experimental closure. Let's recall what an experimental activity is. Here are 3 quotes that capture what an experiment is all about. For Bacon, an experimental activity is a question put to nature, but also it is a task of putting nature to the question. For Collier, an experiment is a window to the world of underlying causes which usually operate unactualized. And for Bhaskar, an experimental activity is an attempt to trigger or unleash a single kind of mechanism or process in relative isolation, free from the interfering flux of the open world, so as to observe its detailed workings or record its characteristic mode of effect and or to test some hypothesis about them. So an experimental activity is necessary precisely because the world is an open system, where mechanisms operate and have effects other than those they would have in experimental situations, due to the co-determination of these systems by other mechanisms or causes. There is no natural or universal closure in the world. Passive observation without intervention is not enough. When you think about it, if the world is a closed system, it would not be necessary to engage in experiments. All we need to do is to observe the world, and already we will discover the causes of the events around us. Let's go back to what happens in a laboratory. We have event A that we hope will lead to event X, and we know that events A and X belong to the domain of the actual. They are events, but they are linked together by an underlying cause. If you recall, to achieve the result that the scientist is aiming for in the laboratory, he or she has to make sure that he controls the variables and does not allow extraneous variables to get in the way of an experiment. Now, what is important here is that while event X is the effect, event A is not the cause, but the condition. Causes, after all, are not empirical, since they do not belong to the domain of the actual, and causal laws are non-empirical. Here's an example. Not brushing your teeth is a condition that triggers the cause, which a scientist would tell you would be bacteria that build up to form the plaque that leads to tooth decay. Let us try to further unpack the depth stratification of the world. What do we mean when we say that the world has 3 domains? The domains of experiences, of events, and of causes. There are 4 possible scenarios here. The first scenario is that a cause exercises its powers and yield outcomes that are actually perceived. In such a case, we cover all 3 domains because causes exist whether they exercise their powers or not. But in this particular case, there is an outcome, there is an event, so we cover the domain of the actual, and the outcome is perceived, so we also cover the domain of the empirical. In the second scenario, causes do exercise their powers and they yield outcomes, but the outcomes are not perceived. In this case, we cover the domains of the real and the actual, but not the domain of the empirical, because the outcomes have not been perceived. In the third scenario, causes are triggered to exercise their powers, but because of the open system of the world, other causes have intervened and no outcome has been produced. In such a case, we only cover the domain of the real. There is no outcome, no event, and certainly no experience of any event. So the domains of the actual and empirical are not covered. There's a fourth and final scenario. Causes are not triggered. The conditions are not present to trigger the causes to exercise their powers. In such a case, only the domain of the real is covered, because the causes exist, they are there in the domain of the real, even when they're not triggered, but there is no event, and there is no experience of an event. In the four scenarios we just discussed, the third scenario, where causes do exercise their powers, but there are no outcomes, that shows us the open system. In an open system, causes interact and co-determine or cancel out events. This is why it's possible for causes to be triggered by conditions so that they exercise their powers, but they nevertheless yield no outcome. Let's examine the difference between a closed system and an open system. In the closed system of the laboratory, because of experimental control, we're able to remove the extraneous variables that might affect the outcome. So what happens is that event 1 leads to event 2 because of the triggered cause. In an open system, even if the cause has been triggered, we may not have the same outcome. Event 1 may not be followed by event 2 because of the intervening causes that are active in the open system and are not controlled. So what may happen is that event 1 can lead to event 3 instead of event 2, even if the same cause is operative. Here's an example of what happens in a closed system. A ball rolls off the table, and then the ball hits the floor because of gravity. In an open system, it is quite possible that an intervening cause may prevent the ball from hitting the floor. So after the ball rolls off the table, it's possible that somebody decides to catch the ball, and instead of the ball hitting the floor, I catch the ball. Here's an example from economics, the law of demand. According to the law of demand, the quantity of a good demanded falls as the price rises. But as the price rises, the quantity of the good demanded falls. Now note that the law of demand does not determine an event. Rather, it acts as a tendency, which brings us to a redefinition of causes. Causes do not determine events. Causes operate as tendencies. So that all things equal, the law of demand might lead to these outcomes. Can you think of an interesting example of the world acting as an open system? Can you think of a cause that has been activated by the right conditions but remains unactualized? That is, it does not yield to any outcome because of other causes interacting with it. According to the positivist and successionist view of causation, made popular by Hume, the preceding event, event A, is the cause that leads to event X, the effect. But this is not causation. This is mere correlation. Causation tells us that the preceding event, event A, is only the condition that allows or triggers the cause to operate and lead to the effect of event X. This is the critical realist view of causation. In the open system of the world, there are other causes that are active and intervene and co-determine the effects. The concept that the world is an open system where different causes interact and co-determine events leads us to rethink what causality means. Causality is not necessary correlation. Causality is not about the regularity of events or the constant conjunctions of events. Rather, causality is necessity without determination. Causal laws are about tendencies of acting in the open system, which may or may not be realized in any sort of outcome. So when you think about it, causal laws are like a game of chess. You seldom determine the play, but no one breaks the rules. Causal laws define possibilities and limits of how things act in the world, but by no means do they dictate the outcomes. Causes are tendencies. They do not determine events. This refutes the notion of determinism. Determinism is a doctrine that all events, including human behavior, are completely determined by natural laws. Hence, there is no free will. We should not be held for our actions. But this has been refuted. Causal powers are tendencies in the open world. All they do is they set possibilities and constraints. They do not determine events, and for this reason, they cannot predict events.